All right. Um, Good evening, everyone. Thank you for joining with us today. And we have a very special guest today talking about uh, constellations, not just constellation, but satellite constellation. We have Mr. Pranit, who is the co-founder and VP of Business Development at Galaxeye Space, a deep technology startup building an advanced constellation of Earth observation satellite. Uh, he currently leads the business strategy, sales, and marketing at Galaxeye, having pursued his dual degree program in engineering design at IIT Madras. He has been associated with the Team Avishka Hyperloop as a team head prior to graduation. He was also awarded the best student entrepreneur on campus, while a- at the institute, Pranit is also qualified Mensa member, Lean Six Sigma, Green Belt Executive, and Certified Innovation Management Associate. I hope you will enjoy today's session and learn more about the company and Galaxy as well as the importance of Earth observation satellite based on satellite constellation. Pranit, over to you.
Great. Thanks, Prathamesh, and hi, everybody. Really nice to be part of this event. Right, good to interact with you guys. So, a very brief introduction, right? And what I'll do is, try and take you guys through what Earth observation really is, and a few examples in showing why it is important, what kind of impact can it have, right? Now, through the present, I've kept a very brief presentation, nothing more than 15 slides, if I remember correct. Right now, the idea is to have some sorts of an explanation on why Earth observation is important, and then coming to what we are doing at Galaxy, right? So, with that context, I'll just go ahead and share my presentation and also give you like an introduction. So, at Galaxy, right? We are so essentially we're a young startup. We're not somebody like ISRO who's been here for decades or any other commercial company who's been here for several years now. We're a young startup. But why did we choose Earth observation? Right. So we could have. I mean, there's a lot of trends in the industry today. There's artificial intelligence. There's currencies, crypto, and fintech, and Web3, and this metaverse, and so much happening. Right. We chose EO because of the impact that it had, because of the kind of innovations we could bring in, right? And today I'm grateful to NSS having given us the opportunity to talk about this impact and really kind of communicate with you guys. Where, as I understand, you guys are space enthusiasts, right? So are we. And why did we choose EO is something that I want to translate to you. So by the end of this webinar, you stand with the notion that Earth observation is, there's some myths that I'd like to bust, right? Earth observation, number one, is not just a thing of the government and the defense, right? There's a lot more to it. Number two, Earth observation, even commercially, is just at an early stage. There's so much scope for innovation. And lastly, it is not just to businesses again. So I'm slowly expanding the audience and saying that even users like you and me can benefit with Earth observation, right? That's how important they are. And today, especially looking at satellite constellations, right? There's so much happening and there's so much concern related to space debris. There's so much of things related to companies like Starlink, OneWeb, and so on coming up with large constellations. Now, given all of this, where does Earth observation fit in? Like, can we really overlook this? Is the question that we need to be asking. So I'll just dive into my presentation and take you through a very brief introduction video of what really Earth observation comes to and how is Galaxy pitching in, right?
Pranit, if you're sharing a video, can you try going into your settings and checking if you have shared device audio as well?
Sorry, I heard somebody saying something, couldn't hear. Hello?
Yeah.
Yeah, I just heard somebody saying something, so I wanted to check if I missed.
Yeah, actually, the device audio is off from your end, so can you turn that on so that we can hear the video as here?
Got it. I can replay. There's just some background music though.
Yeah.
Let me reshare in that case. So as you might have seen, okay, I won't be able to share the audio by the way because I'm sharing a window.
Okay.
So nevertheless, basically, the Earth really looks like. And when I say step far, I'm talking about something like 500 kilometers. Right? That's the low Earth orbit. That's the altitude where most Earth observation constellations are. Right? Now, at that altitude, we're talking about good quality Earth observation. Right? That's the focus that I'll move to in a slide. And to give you a context of where I am coming from, where Galaxeye is coming from, is we have raised funding rounds, we've gotten support from various governments, incubation cells, won some grants, and also expanded as a team, got some media attention, right? The question being space technology. So, as a young startup, right, we got through all of this in a very short span, right, because we're a space tech startup. Now, today, if you go talk to anybody saying, are you interested in space technology? The most common answer would be yes, I am, right? And at least in my experience talking to people, one thing I've seen is at some point in their life, people have always dreamt of becoming an astronomer, right? So why? Because space is really fascinating. And to be honest, space is really wide, right? So if anybody has any thoughts, and if you have access to the chat box, right, anything that you can share out saying, what comes to your thought when you hear space technology? Anything, could be a movie, could be some person, could be some technology, could be some experience, anything that you can share. Space technology, what bells does it ring? Rockets, sure. Some of the most fascinating things, yes. I think that's become a saying, right? That this is rocket science, and this is literally rocket science, right? That's what space is about. Anybody else? Any comments? Okay. In that case, what I'll do is I'll probably speak for you guys and tell you what space technology. Traveling to outer space, absolutely yes. Right. That's also one of the pointers that I'm covering. This is outer space that you're talking about, right? It could be the Milky Way galaxy. It could be the International Space Station. It could be the movie Interstellar itself, right? Could be an astronaut, could be Elon Musk, could be constellations, could be weather, could be imagery monitoring, communications, rovers, NASA, ISRO, space tech, right? Now, all of these things that you see, there's so much that space technology covers. And today we're talking about numbers being at $425 billion. That's how big the global space economy is. If you say global space economy, right? This covers all the defense, all the commercial applications, the research, and everything. But this is a huge market. And why I'm saying it's a huge market is because of the innovation that it has, and because of the kind of applications that it can serve, because of how downstream it can get, and how important this becomes, right? What we are going to be talking about is one sector of this big market, which is the Earth observation based satellite constellations. Now, getting to the point of this whole webinar, why is it important, right? Now, if you look at it, if I were to state it to, let's say, a very first standard kid, what would I say? That, hey, I'll take you to space, I'll have a mobile phone, let me take a picture, right? Isn't that what Earth observation is? So I'm going to be traveling, taking a picture, and I'm essentially observing Earth, right? And that's the most blunt thing. The question is, why would you do that, right? So it's a purpose that's more critical. Now, it could be to capture very fancy buildings like these, where you just want to see how different buildings look like right from the top. And for example, again, I'm kind of building a hypothesis here, but most of us open Google Maps, scroll through, and find how our home looks like, right? And that's actually from space. That we're looking at. Or it could be an example where recently a company captured this image of a Thanksgiving parade to show the amount of the kind of crowd that people bring in, the kind of celebrations that happen. Now, these are things that you might probably have to spend quite a few thousands to really travel to the US and witness something like this. But imagine sitting here doing that from space, right? Or even getting some very fancy abstract images. It could be phone wallpapers, laptop wallpapers, and so on. Right? There's so much that out there. The question is, are these really the reasons that we need to spend millions of dollars and put up satellites in space? I'm sure this is not the only reason, right? The reason that really drives all of this is sustainability. And when I say sustainability, I am referring to the United Nations Sustainability Development Goals. And I'm sure you guys must be aware of what the UN SDGs stand for, right? So United Nations came up with a bunch of goals, to be precise, 17, wherein it said that these are goals that we need to meet by 2030 to really be able to sustain ourselves as a civilization. Right now, to bring all of these to context, these goals range from things like calling out no poverty or zero hunger, health and well-being, education, water, sanitation, clean energy, and whatnot. Right? Now, all of these 17 goals that you see, right, can be measured in very different ways. Right now, people measure this using on-ground surveys. You must have seen all of these, census surveys where people come home and they're like, "How many people are at your place? Are you having enough food resources? And is there enough health, sanitation, and things around this region, around this area, and so on?" So all of these define sustainability. This is what is happening at a global level. Why I'm talking about this is because Earth observation is one really critical factor here. And when I say really critical, it is that one technology source that can actually impact all of these 17 goals. Right now, of course, if you ask me how will it, let's say, let me take goal number 5 as example, right? Now, goal number 5 says gender equality. So the very obvious question is, how will I monitor using an image from space whether there's gender equality, in the various measures and various steps being taken and whatnot, right? The answer is you're right. It's not that all of these goals are directly impacted, but if you look at it, if you really read in depth about how sustainability development goals are defined, there are some direct indicators, right? There are certain targets, and then there are also some indirect indicators of how you can measure. For example, if you want to, let's say, track any of these goals, right? There's a few indicators that I've listed down here. Things like tracking population distribution, mapping cities and infrastructures, the topography maps, land covers, ocean observations, water quality, and so on. Right? Now, all of these can really help you get some sorts of indications. And out of these 17, 14 such goals can be directly impacted. For example, you can really talk about sustainability, you can talk about infrastructure, you can talk about economic growth, climate action, life on land, underwater, and so on. And the three such goals that are indirectly served, but they can still be addressed. And that's the power that we are carrying with Earth observation. Right? Now, when I say Earth observation, I'm really looking at the bottom line saying that I'm observing some geography on Earth, right? This can give us a lot of insights, right? To give you an example, if you really understand the space that I'm talking about, and when I say space, I mean Earth observation. Right? So if you look at this space, now look at the applications that we could be solving. There's a gamut of applications. So let's take an example of mining and energy, right? If you look at a mineral, if you look at a mine, now you're going to be spending quite a significant amount in mining in that region. The question is, which regions should you really go after and until what level, right? How do you know if the material is raw enough, if it's a good ore, right? Or how much should it be processed and things like these? You can really track such health parameters from space. Right? Similarly, for agriculture, you will know if your farmland is well irrigated, and you can actually measure the water content. You can measure if your crops are in good health or if there are dry leaves around. Right? In fact, there was a case where some company actually used satellite imagery to understand the impact of pests and other things on a given farmland region, and really be able to track and say that, hey, you have n number of hectares in your farm, but this particular geography is more prone to pesticides for ABC reason, more prone to pests for ABC reason, right? Now this could be the soil parameters, this could be the crop health, this could be any factor, right? So that's how you really manage your vegetation and predict and insurance and so on, where they're very critical use cases. And almost every time that you notice that there's any disaster, right? Like there's a lot of forest fires happening, be it in the US or right now it's Spain. In fact, even in India, very recently in the north around Uttarakhand, and there's floods that come up and so on. There's so many disasters. How do you track how changes are happening, right? It's not easy for an on-ground team to just go and assess the situation. And when we look at disasters, we are talking about really large areas, several square kilometers, right? So when we look at areas like these, how would you get an insight? You can't have 100 people spread out in different zones of the city and everybody updating, hey, situation here is good, or here situation's okay, I will need some resources and so on. This is not possible manually, and that's where Earth observation really adds a lot of insights and says that in this region, this geography is something where you need to send out resources. This geography is where assets are damaged, but there's not much of human loss given the kind of area. This region is pretty safe from the disaster and so on, right? So these are the kind of applications, these are kind of situations where Earth observation really plays a role. Then talking about something like a real estate, wherein you will be looking at how a particular construction happens, right? So I'm not sure how many of you have been to Dubai, but I was recently there for this conference, right? The IAC, and so there I just happened to visit I just visited Burj Khalifa, and if you go through that tour, which is actually the tallest structure right on Earth, and if you go through the passage there, you'll really see different images of how the building was constructed, right? Now, all of these things you will capture through satellite imagery. And so you know how much time it took, at what stage was it, how's the building really being constructed. So yes, it can of course be done with forces on ground as well. But think of this in very different scenarios. Example one, where you are a construction company and you have some 100 properties spread across the world. Right? Would you really care to talk to each one of these 100 people and understand how the status is? Or would you rather prefer a report on your table saying that this particular building progressed ahead and there were 2 floors extra constructed? That's the kind of detail you can get from satellite imagery, by the way. Or imagine another scenario where more of a defense application where you want to see if there's any new construction happening, right? Which is my last application here on. If you really want to monitor activities around the border, and that's something that has a lot of use cases, right? Defense needs a lot of data. Security, it's a matter of security. For example, recently the Russia-Ukraine situation that we dealt with, there was a lot of imagery floating around, right? Some images that said these buildings are damaged. Some images that said that there's new, lining of trucks entering the city. Some images that said that there's new ports or there's new infrastructure being constructed around the borders and so on. How do you know all of these, right? And it's not a situation where any Tom, Dick, and Harry can just go to a place and say that, let me see if the area is safe. It doesn't work like that. And with internet being disconnected, even worse. Right? That's where satellite imagery, that's where Earth observation plays a role, and it really helps in decision making. In fact, that's a very good example to say where even the governments realized, right? For example, if you look at Ukraine as an example, it's during those couple of months where they signed quite a lot of contracts and to really get a lot of satellite imagery to understand how their region is, right? Because they can't communicate with somebody on the border. But if they want to know what the situation is, that's where it helps. So it's also personal security. It helps in very different situations as well, right? And another use case is really, excuse me, really tracking the health intensity. When I say health and intensity and so on, it's, let's say you have, imagine yourself sitting on the chair of a CEO of a company like Shell or an ExxonMobil, right? Now you are monitoring several thousand kilometers of gas pipelines. In a country like India, it's a very big challenge, right? And in fact, even abroad, right? Imagine dealing with such a huge pipeline. And what we're talking about is really the challenge of ensuring that the pipeline is in good health. One stretch of your pipeline could be dealing with different weather conditions, extreme heat or rains or whatever, that could affect the structural strength. Another stretch of your pipelines could be dealing with, let's say, theft. There'll be somebody who's going to be coming in, stealing out, or there's so many cases that companies have dealt with. Or imagine a case where you are sitting and there's a stretch where there's a new construction that's happening, right? So people are really digging through the ground, and that disturbance on ground affects your structural stability, right? And that causes some cracks in your pipeline. Now, all of these require a lot of constant monitoring. And to be honest, the way people do it is really send out a human on ground, right? And the similar thing goes for transmission pipelines as well, right? So imagine a person just like you and me walking along the gas pipeline or under a high power transmission line and trying to monitor the health, right? Imagine the risk, imagine the kind of inefficiency that we're dealing with, right? So there's one person who walks something like a 3 to 5 kilometers every day to monitor if the infrastructure is in good health and so on, and then that guy reporting to the region head and so on, right? So that there's a big hierarchy. So many applications like these, right? Now there's so much benefit, so much decision making, so many stakeholders. That's the kind of volume that we are dealing with. So I hope this becomes a little clear on why Earth observation is really important. To give you an example, right, if we look at flood monitoring in specific, so we did this case a few months back. Chennai dealt with some floods, and we went on to use satellite imagery, run our own analytics, and come up with an insight on where did the floods really hit the most, right? There's so many relief efforts, and you see the state government, central government, putting out relief funds of several lakhs, several crores. Right? Now, all of these are taken as decisions based on what? Based on data, right? Now, satellite maps, I'll take you through this a very brief video again, talking about how satellite imagery can really help you understand the kind of damage that has happened. So if you look at it, so here I'll just pause and explain in a little more detail on what optical imagery and SAR imagery is in a couple of slides. Some of you might already be aware, but for now, just take it with a pinch of salt that, you know, optical images, the way we capture images might not really give us very good insights, right? Imagine like during floods, this is an image that we get, covered with clouds. And then what do we do is look at different kinds of imagery data. And these are things using things like radars. So here it's called synthetic aperture radars. And these give us images penetrating through clouds and different weather conditions. So here's what we did. Right? We had our own flood detection algorithm. So we ran this algorithm, identified which are the flood affected regions, and detected changes in that span of 1 week, 10 days, right? Of when the flood came, what was the state of infrastructure before, and what's really the state post the disaster. And that really helps us understand what kind of a situation are we dealing with, what kind of relief efforts do we have to put in, and so on. And this is one application that we had. So if you look at Earth observation, right, we've spoken a lot about the applications and everything. Now, getting to the second part of it, right, Earth observation based satellite constellations. So today, Earth observation or remote sensing, right, can be done using different sources. There could be industries or businesses or governments who benefit, but these can be done using things like drones or UAVs. It could be done using airplanes or satellites. If you look at these three, they're very challenging technologies. They're very, let's just say, very different technologies. Right? If you look at drones, today drones are slowly expanding into the market. There's a lot of use cases coming up. But imagine again sitting here and wanting to fly a drone in Delhi. Is that possible? Unless you have a partner there, I don't think so. Right? And even if it's a region around you, imagine the scale that you would be looking at. Now, a drone, let's say you're able to fly to n meters altitude, and you're able to travel to, let's say, n number of kilometers in distance, and so on, right? Now all of these things can happen until a particular limit, right? But beyond that, it has its own power restrictions, range restrictions, and so on. And that's where airplanes come in, because they go at a much higher altitude, have a much larger time span of operation, so they can capture much large regions. But look at the cost, right? How expensive would it be to really put out a satellite image for every map that you needed, right? And then again, of course, being subject to weather conditions. So imagine wanting to fly during a flood, right? It's really not a thing. That's where satellite image comes in, where you're really alert to all of these on-ground situations. You're actually out there in space, out of the world, and you are now having the capability of capturing images irrespective of weather conditions, and whatever situation it is on ground, whichever geography it is, however large it is, and so on, right? And with satellites today, at best people are talking about something like at the least, sorry, people are talking about something like a 200 300 square kilometer area which can cover a city, right? At least in the Europe, and even in India there's much larger satellites, right? In India, cities are roughly around 500 600 square kilometers area, and today there are satellites which can even capture 10,000 square kilometers area. So imagine the kind of capability that you have on dealing with data sets, right? On really getting information, right? As against something like a drone or an airplane as a data source. Of course, drones and airplanes have their own use cases. For example, with satellites, you are looking at 500-kilometer altitude. So your resolution, right, the image quality is to a certain extent. But with drones, it's much, much better. In the sense, to give you some numbers, satellite imagery today at best is captured at like 30 centimeter resolution, which means 30 centimeter by 30 centimeter on ground is 1 pixel in the image. Whereas with drones, people are talking about 1 2 3 centimeters and so on. Right. So it really depends on the use case and everything. And satellite images are a need, because you will need a very big picture. And then, of course, you can boil down and then use drones, but satellites will still remain a very active source. Talking about value chain of how this arena or this sector really works is, you know, there are satellite systems where companies build, satellites. These are like hardware companies, right? And then there are data companies where, we really capture data in space, right? And satellite systems, how they're different is, now satellite is not just simple as putting up a camera, right? It's really talking about aspects like battery packs, solar panels, control systems, and so on. There's so much more, and I'm sure you guys are pretty aware on that front. So there's satellite systems, then there's data that we're talking about, and then there's applications where you're really talking about analytics and AI. That's where all these machine learning, deep learning algorithms and things come in. Right? Now, that's the norm today. To really work on getting this value chain as efficient as possible. And at Galaxy, this is where we fit in, right? Of really capturing good quality data, right? And hence impacting the applications end of it. If you ask me, aren't there satellite data providers today? Of course there are, right? And we have been getting imagery data. The question is, what kind of Earth observation satellites are there today, right? How are these constellations structured? The first set is an optical sensor, right? Wherein we are talking about images like these, where you will only get an image if it's a clear day, right? To give you an analogy, think of an optical sensor as something wherein you're flying in an aircraft and you capture an image using your mobile phone, right? When you take that, you are basically saying that, hey, I will want my plane to come to a very clear region so I can capture an image. If not, I'll only see the blanket of clouds, right? Now, that does not help you do analytics. Similarly, during nighttime, the image is not meaningful except if you want to see night lights, right? So there's not much of availability for an optical sensor, whereas it comes with a lot of information if it's really captured in good weather conditions. You can really see and tell details like how many cars are parked outside a store, or how many ships are outside, or if your infrastructure is in good health, and so on, right? Now, there's a lot of information that you get, but there's very limited availability. And the other sensor, again, in the video that we referred to, was SAR, synthetic aperture radar. What's different is that we get images irrespective of the weather conditions and time of capture. And now, when I say irrespective of weather conditions, this is because of the way radars operate. Right? So these are imaging radars where the signals are sent from the source and the reflections is sent back, and that is translated to an image. Right? So you get a lot of availability because you can see through clouds and even during nighttime. But the challenge is the very limited information that they carry. For example, if you look at the same region here, you see here to the bottom left, right, of the optical image, you'll realize that you do not see any objects per se except these pale red dots that you're seeing. Whereas it's in SAR, you can really identify and say that there's a different object because different things on ground reflect back radar signals in very different manners. On the other hand, if you look at the ground regions, you know that this is ground, right? And probably you zoom and get really good quality images. You know these are some objects. This is some kind of vegetation, some kind of infrastructure, and so on. But that does not give you the capability to identify what kind of a structure is it. Let's say, for example, no, is it any building? Is it a ground? Is it, let's say, a shopping market? Right? Because the structures are very different and they can be classified. That's what AI algorithms help in, right? Now, there's very limited information that this gives you, and this is the gap that we at Galaxy are solving, wherein Earth observation has a lot of applications, right? But today's data, it has some sorts of compromise. So what do we do is basically we are building our own satellites equipped with Drishti sensor. Now, Drishti sensor is basically something that we filed a patent for, wherein we will capture optical and SAR images from the same satellite. Now, this is something that we're doing for the first time, right? And the idea is to really have the capability of capturing all the information that you want, irrespective of the weather conditions. So you'll get images even during nighttime. You'll get images, even if it's a flood for that matter, because you can see through clouds. You can see through smoke in case of a forest fire and so on. So this is the kind of a data set that we are talking about right now. This will be obtained on the edge. And when I say on the edge, again, this is a very emerging trend that I'd urge you guys to look at of, edge computing. Right now, there's a lot of capability that we're talking about, wherein we're looking to process data on space, right? Process data in space on the satellite itself. And that helps us optimize a lot of the problems. Let's say, for example, if you're capturing an image and it's covered with clouds, right? You don't know that your region is covered with clouds until the image is captured. But then one image that sizes to something like a 10 GB, right? Why would you want to downlink that 10 GB, store it, process it, and then realize that, hey, it's covered with clouds? Instead, if on the satellite itself, if you were able to identify that the image I captured, more than 60% of it is with clouds, which means I cannot use it for analytics. So let me discard it. Let me not downlink it, right? That's the capability that we are adding on. And to scale it up, we're looking at a constellation of satellites that orbits the Earth, right? Now, when I say constellation, why are we looking at not just one satellite in a constellation? Fairly obvious, but it's just to get much more coverage. So with our constellation, we are looking at mapping the whole Earth in less than a day, right? And then be able to revisit every region so frequently. So you're really getting a lot of insights, and understand that the end goal is to make decisions, right? And the guys making decisions are not the guys who care what battery goes into a satellite, right? What they care is, I want good quality data 10 a.m. every morning on my table, right? That's how I will make a decision, right? That's the gap. That's where all the innovations are coming up in the industry today. Coming towards the end, here's where I'd like to leave you all with some kind of questions, wherein how are we working towards the goal of sustainability, towards the goal of really utilizing technologies like Earth observation, right? And this is a very, a very good phenomenon that we at Galaxeye follow on why, what, and how. It's called the golden circle, wherein anything that you do, right? The first question you ask is why, what is the purpose? And then what am I doing about it? And then how will I achieve it, right? Now, these three layered questions, how are we answering at Galaxy is we are looking at the purpose of having extensive reach of satellite imagery. And at the end of the day, be able to commoditize it. And when I say commoditize, it's talking about users like you and me. So let's say, for example, if I have a building being constructed and I want regular updates, I should be able to get satellite imagery, and not by paying some $100, right? But let's say paying $1 for the complete image. I don't mind spending $1 a month, right? Imagine that kind of a vision, that kind of a commoditization. So that's the kind of reach that Earth observation should really get to. And that way we'll really access the untapped potential, right? That's the purpose of us really looking at Earth observation as a sector of impact. What are we doing towards this purpose is building the smartest digital twin of Earth. Right? So as you capture images, you really build a lot of insights of any region. And as you map the entire Earth, you'll be able to say, like on Google Maps, right? So I'm sure a lot of us have tried this activity where you just scroll as much out as possible and you'll be able to see the complete Earth. And then just roll it around and you'll be able to zoom into any region, because that's how close a digital twin that has been created using satellite imagery. Right now, how are we doing it is we are enabling that by the kind of data that we are capturing, by the kind of economics that we're looking at, making it much more commoditized and so on, right? So the question that you should be asking yourselves is, how can I answer these questions of why, what, and how, right? How can I use Earth observation as a tool to really serve a certain purpose? Now, these are some questions that I'd like to leave you with. And as you ponder, you'll realize that, again, Earth observation is one sector, right? And like I started out with, space technology is a really wide gamut. And when I say really wide, we know how endless it is, right? Now, looking at that in vision, how do you think you are positioning yourselves to bridge that impact? You are positioning yourselves to serve a particular purpose, build some technology, and really make it happen, right? Now, this is where I'll pause and I'll open up to questions wherein we, for us, the longer vision is to become eyes and brain in space, right? Earth observation is something that we begin with, but how we'd like to take it forward is to have an infrastructure across different planets. And at the end of the day, be able to get as much information as possible, have eyes, have brains in space, have a compute infrastructure, and really scale things up to as much as possible, right? However, first step being, let's look at Earth in the best way possible. Thank you so much. I hope it was relevant. You learned something new, and you do relate and take back something from this webinar. So happy to address any questions you might have.
Thank you so much, Pranit. It was really good session, and I hope everyone has enjoyed it. And participant, I request you to put up your questions if you have any in chat. Okay, there is someone who has raised their hand. We'll just unmute them. Okay, you can access your mic. Please feel free to access and ask your question.
Hello, thank you so much, Pranit sir. It's a very beautiful session. But unfortunately, I joined the session very late, approximately 10 to 15 minutes ago. But I want to know one thing that if I actually I just graduated in mechanical engineering, right, in 2019. Okay, so I think just to start thinking in the areas of the startup in the space sector, like Galaxy's Eyes is yours, and also something around more technical about rocket like sky routes and all. So can you please help me the how I thinking start in this area so that I or we can move in the areas of startup to the open a new mind or start in the areas of space. Are you getting my questions? What I want to ask?
Interesting. No, very good question, and I appreciate the thought itself, right? Uh,
Yes, thank
to
you.
give you some context, space is something that everybody wants to get to, but to look at it as a startup is something that requires a lot of, for the lack of a better word, let's say guts, right? Why? Because we are talking about an industry that has remained with the government. There's very large organizations like NASA, ISRO, who have been into it for decades. So for youngsters like us to come and impact is really something that of course needs to get a lot of thought. So in my opinion, how you should be looking at it is India is one country today where you should be if you want to work in the space sector, right? Because India is just opening up to privatizing the space sector and so on. And as youngsters, what we should be looking at is the factor of innovation. Why I'm mentioning the India privatization and all of those things is because the sole reason of privatizing a sector is to tap into that idea of innovation. You do not want to be building a rocket that would take, let's say, 5 years to build
Yes.
and not having any business sense, right?
Mm.
So is there any new factor that you bring in and say that, this is what ISRO has been doing, this is what any other company commercially has been doing, but I have something really different. I have something, some actual innovation that has commercial sense, right?
Mhm.
Space is, I mean, today everybody's talking about tech startups, right? There's
Mm.
consumer tech. Even let's say if you have an app, it's technology. So space, I see it as deep technology. Right? It is actual technology and engineering. But on the other hand, you really need to couple that with some sorts of a business sense and then look at how is there an opportunity that you can build. So if you are thinking that you want to build another SpaceX in India, then I probably suggest that you reconsider on the idea itself, not on starting up, but on what idea are you building upon, right? Because space is
Mhm.
a global industry. I can have a satellite and launch it with SpaceX. It doesn't matter. I don't have to necessarily launch it with somebody like Skyroot or Agnikul.
Mhm.
Right? Unless you have that key differentiation, it becomes difficult for you to really hit the market. For example, in our case, the sensor itself, the kind of data that we are capturing is different. And that is why we have been able to talk to people across the globe. That is why people are listening to us and conversing and so on. So really do that research, see if that idea makes sense, talk to people in the industry, see if there's any commercial sense. You don't want to end up and become a research entity where you're just applying for funding grants and building technologies, right? That's not a startup. Of course, it's not wrong, right? You take a call on if you want to start up, you make sure it has a business sense. If you want to build a research company, of course, space is a really good sector for that as well.
Mhm.
I hope this answers, and if
Yes,
there's
yes, of
anything
course.
specific.
Thanks, thanks.
There is one question in chat uh, asked by Chinmay. I want to ask about how can we start with deep learning and machine learning projects and some related resources in Earth observation.
Great question again. For example, there's not been a day that I can recollect where we've not spoken about analyzing data using MLDL algos. And why I say that is because Earth observation sector today is at that juncture. Right? If you look at it a few years back, when the whole term of big data really cropped up, where we're dealing with huge volumes of data, huge varieties of data, and so on. Now, Earth observation is at that juncture today. So if you're considering getting into something like MLDL on Earth observation, it's a good call. How do you start about it? Is there's a lot of resources that help you, perform satellite imagery analytics. You don't need to spend anything per se, right? There's open source satellite imagery. That is what the European Space Agency, NASA, ISRO, and all of these guys have been putting out through their satellites. So it's open source imagery. There's quite a lot of open source algorithms and so on, which you can try. Like the most basic thing is, uh, for example, like you see your laptop display, right? There's R, G, and B. Now, similarly, there's multiple bands, and some band arithmetic can give you insights. Like, for example, there's this index called NDVI, which is more or less like a hello world in the satellite imagery analytics game, wherein it's simply A minus B by A plus B sorts of a formula, and that will help you understand which regions are well vegetated and which are not. These are very arithmetic applications. And as you get to complexities of, let's say, segmentation or clustering or classification, and in all of those layers, in all of these things, you are talking about satellite imagery as an example. Right now, all of that, if you start with very small applications, start stepping up, look up for different resources. If you go to ESA's website, the European Space Agency, there's something called as the Sentinel. It's called the Copernicus. Similarly, if you just look at GitHub as a repository, there's a lot of algorithms up here and so on. So you'll be able to find some resources and then dig deeper. One thing that I definitely leave you with is, if you look at satellite imagery analytics today and actual computer vision today, there's a lot of gap, right? Computer vision is here and satellite imagery is still here. There's so much to do, right? So if you're really looking at this, then there is enough scope for you to build a career as well. So do start out with small projects, and then you'll be able to scale.
Okay, so there's Tushar, and he wants to ask you a question in Hindi. Tushar, please go ahead.
Hello, I'm audible. Hello, I'm audible.
Yes, Tushar.
थैंक यू मेरे मुझे मौका देने के लिए सवाल पूछने के लिए। मेरे 3-4 सवाल है। सबसे पहले ये सवाल पूछता हूँ कि सैटेलाइट हम लोग अगर मैं गलत नहीं तो आप सैटेलाइट बनाते, कमर्शियलाइज सैटेलाइट करते, तो सैटेलाइट किस तरह से डिजाइन किया जाता है? उसके लिए कौन सा सॉफ्टवेयर है? ऐसा कि कैसे करते हैं आप डिजाइन कंप्यूटर के अंदर? फिजिकल तो बाद में होता है, पहले कंप्यूटर में स्केच वगैरह बनाते होगे आप, तो वो कैसे होते हैं उसका मुझे जानना था। और उसके बाद ये दूसरा ये सवाल था कि सैटेलाइट से जो आप डेटा आता है धरती पे, जो इमेज होती है वो सब कुछ होता है, वो एनालाइज करने के लिए हम लोग क्या कर सकते हैं खुद से घर पे, या कुछ वेबसाइट इस तरह से उसका डेटा एक कर सकते हैं? और भी सवाल है, इनके बाद में पूछूंगा। बाकी पहले बाकी के सब सवाल के जवाब दे दीजिए। थैंक यू।
श्योर। तो पहले सवाल के लिए ऑन हाउ वी डिजाइन अ सैटेलाइट, तो ऑफ कोर्स इट्स अ लॉन्ग प्रोसेस, राइट? जैसे हमारे केस में फर्स्ट इज लाइक एकदम सिस्टम लेवल आइट्रेशन कि मेरे सैटेलाइट का पर्पस है। इफ आई एम लुकिंग एट अर्थ ऑब्जर्वेशन, व्हिच मींस आई नीड अ कैमरा, राइट? इन आवर केसेस, हमारे केस में वी आल्सो नीड रेडार्स। तो यूजिंग दीज टेक्नोलॉजीज, मेरी पावर रिक्वायरमेंट क्या होगी, कितना मास बढ़ेगा विद ऑल ऑफ दीज सब सिस्टम्स, right? And getting that power budget, mass budget, volume constraints, and so on. फिर looking at individual components, कि जैसे if I want, let's say, 10 kilowatts of power to be put up on satellites, क्या वो possible है, right? And if that is possible, तो मेरे सैटेलाइट का वॉल्यूम क्या होगा, right? So there's a lot of trade-offs. तो वहां पे in most cases, I always you start with paper calculations, फिर Excel sheet, and then slowly move to some kind of different system designs, right? Subsystem level पे कि मेरा कैमरा इस तरह से डिजाइन होगा, फिर मेरे कंट्रोल सिस्टम्स की रिक्वायरमेंट्स ये होगी, कैन आई गेट इनफ कंपोनेंट्स एंड सो ऑन, right? And that's how you go on building a satellite. It's a long process, right? क्योंकि काफी trade offs होंगे, there's a lot of optimization that needs to be done because every kg that you add comes at a cost, and today launch cost of every additional kg is somewhere around, let's say, $15,000-20,000, right? So it's not कि अच्छा power कम पड़ रहा है तो मैं एक और बैटरी लगा दूं. Your battery could be just a few $100 or few $1,000 or whatever, but उसको launch करने के लिए you will pay $10,000 extra or $20,000 extra. क्या वो उतना worth है? Right? These are questions that you ask in satellite design. And as for image analytics, of course, open sources, as I was answering, if you just Google and download, जैसे ISRO का भी there's this portal called Bhuvan, right? तो वहां से you can download satellite imagery and run your own algorithms, जो वापस you will find online. Just look at satellite imagery analytics algorithms, right? GitHub की भर के you'll find repositories. There's just tons of algorithms out there. And the good thing is कि ये industry is only evolving, right? तो काफी सारी चीजें, a lot of resources are put out in public. It is not very closed door. So take into account that will help you go ahead.
थैंक यू। लेकिन मेरा सवाल है ना, सैटेलाइट डिजाइन कैसे करते हैं, मैं उसको मैं वो पूछना चाहता था। भेजने के लिए वो कितना कॉस्ट होगा उसका, नहीं सिर्फ डिजाइन का, ऑनलाइन डिजाइन कैसे कर सकते हैं? जैसे कि ओपन रॉकेट हो गया सॉफ्टवेयर जो रॉकेट डिजाइनिंग के लिए आता है, उस तरह से डिजाइन कैसे किया जा सकता है? ऐसा कोई सॉफ्टवेयर है, ऐसा कुछ है? मैं इस तरह से पूछ रहा था जिसे समझ सके, और आगे चलकर संभव हुआ कोई संस्था के साथ मिलकर अगर हुआ तो उसके साथ मिलकर काम कर सके और उसमें ये जानकारी काम आ सके, तो इस तरह से बोल रहा था।
So satellite design can actually, I mean, there are some mission design softwares, right? I don't think, at least I have not come across कोई एकदम ऐसे free open source software जहाँ पे you can test. There are of course paid softwares, but I don't think वो यहाँ पे relevant है. Like जहाँ पे you play with values and so on. Right? So if you just search for satellite or mission design softwares and so on, जैसे not able to recollect the company. कुछ official commercial softwares है that help you do that. Let me think about this. अगर वो नाम click करता है तो I'll tell you. But there are a few companies that have this capability, few software. And at a system level, of course, even things like ANSYS or ये सारी चीजें भी help you design the systems. In fact, हम खुद भी ऐसी चीज use करते हैं, right? Be it MATLAB, ANSYS, even things like SolidWorks and so on, right? So ऐसे काफी सारे software है that help you design systems. And overall satellite system design के लिए भी there are tools. I am not able to get that name. Let me think. अगर याद आए तो I'll get back.
थैंक यू। अगर वो फ्री होगा तो ज्यादा अच्छा लगेगा, क्योंकि पेड तो आपको पता है ना
हाँ,
भारत
free
में।
ही I am thinking. Exactly. Free
Thank
ही
you,
I am
thank
thinking.
you.
Yeah.
Okay, so there is one more question in chat. Could you tell us in short the entire process from capturing an image to processing it, uplink, downlink, and then making sense of the data? Also, a little bit about sensors, CCD or CMOS, in terms of hardware and optical engineering used in Earth observation satellite.
Interesting. So, well, if you look at the whole process, right? So ground zero that we start with is I already have satellites, I have my ground stations. And the first step of capturing an image is telling the satellite where I want to capture an image. Right? So my step one would be where I send out a task file to my satellite that this is my latitude, longitude, where I want an image. So as per my orbital mechanics, my satellite gets a trigger that when it is over this particular geography, there's an image that's clicked in. Right? Now that is done with the help of an onboard computer, which tracks it with the help of GPS and things like that. So once that is done, once there's an uplink of coordinates and the task, or for example, if it's a very smart satellite, then we could also talk about processing capability and so on. So that's an information packet that is sent to the satellite. And then there's an image capture, right? So again, depending on the sensor, it could be a camera, it could be radars and so on. So there's an image that is captured, and that image is then stored in the onboard memory itself. Now here is where either I can handle the data on board, process it and so on if I have an edge computer, or the traditional process if I continue. I have an onboard memory unit that stores this data, and the satellite then waits to come in contact with another ground station, right? So it cannot just beam down data. For example, if you have a TV remote, right, you need to point it towards the TV, right? You can't point it out in any other direction. It will not receive a signal. Just the same way, much more accurate, you really need to have a satellite pointing at a ground station and the ground station having a receiver, right? A vacant receiver that is not occupied, that is functional, and of course, all of those things. Where now your satellite beams down the data as a packet again to the ground station. That then gets stored into the ground station servers, communicated to your company servers, and that's where the image processing happens. So the raw data to the processed data, and then you do the analytics, right? So then the processing happens, and then as per the use case, then there's analytics and so on. Right? So that then comes to insights. Right? After the analysis, now I know that this is my average vegetation, or these are the number of objects in my region, and so on. That's like the end-to-end process. And it really depends on how dense or how smart your network is to be able to make this process as efficient as possible. Like capture to downlinking, this is more of a fun fact for you guys outside this, but capture to downlinking today takes somewhere around a week or 2 weeks in traditional operations, right? Today's commercial satellites are trying to come down to something like let's say 1 hour or 2 hours, or something like that. And if you look at very classified high profile satellites with the defense or the governments and so on, people are looking at latency of a few minutes from capture to delivery, because that's the time criticality. And so it's a long process, so many parts, and the more efficient you make, the better it is. And about the sensor itself, so of course, again, different kinds of specifications, different kinds of bands define what kind of a sensor that you are looking at, right? So what kind of capture do you want? Do you want a burst capture, or do you want a single shot good quality capture, and so on? Or that's how you define what kind of a resolution do you require, right? Or if you compromise on the resolution, or if you compromise on the number of bands. Like when I say bands, it could be R, G, B, NIR, SWIR, and so on, right? So it's a bandwidth. Like the visible region is somewhere from 400 to 900 nanometers, right? I can choose any 3 bands, or I can choose 8 bands, or 10 bands, 15 bands, or today there's hyperspectral companies talking about like a 50, 100, 200 bands also in that bandwidth of 400 to 900 meters. So given your specifications, you then choose the sensor type, you then choose the optics, right? So if, say for example, the same sensor, I want a larger swath, then I will have to change some kind of my telescope mechanisms that can help me do that, and so on. So that's how you design an optical system for an EOS. I hope that answers your question, Chinmay.
Okay, so yeah.
Perfect.
Okay, so I don't see any more questions up here. Well, thank you so much, Pranit, for coming up on our platform. And
हेलो क्या मैं एक सवाल पूछ सकता हूँ? आखिरी सवाल है।
okay, Tisha, go ahead.
अगर आपको वो सॉफ्टवेयर का नाम अभी याद नहीं आ रहा है तो फिर आप लिंक्डइन आईडी या ईमेल आईडी आप शेयर कर सकते हैं ताकि मैं आपको मैसेज कर सकूं और बाद में जो आपको जब भी वो याद आए या फिर आपको जो भी पता चले तो आप बता सकें, क्योंकि अभी समय खत्म हो रहा है और मीटिंग खत्म हो जाएगी तो उसके बाद आपको कांटेक्ट कैसे करेंगे तो वो पता नहीं है, इसीलिए थैंक यू।
Sure. So I'll just put my LinkedIn on chat. So of course, अगर दिमाग में तो I'll keep you posted. And any of you guys also feel free to drop connection requests. Right? So you will be updated on how Galaxeye is progressing, and of course the space ecosystem at large as well.
थैंक यू वेरी मच।
Thanks, Tushar.
Okay, I hope everyone has got the questions answered, and if you have, you can wait for 5 minutes. If anyone has any questions, please feel free to ask, and then we can move ahead to close down the meeting today. I suppose not. Yeah, so thank you so much, Pranit, for coming up to our platform today and talking about a very crucial topic, actually. It's not just about Earth observation, it's also about preserving our Earth and where we live in. So it's quite important to keep it keep in check with what's happening around the globe, around the Earth. And I hope everyone has enjoyed it. Do follow us on our social media, and we'll soon put up this video on YouTube. Do subscribe and share with your peers. Thank you.
Awesome. Thank you so much, Prathamesh
सर
and
जी
team. Really
हेलो
nice.
सर जी एक आखिरी सवाल पूछ सकता हूँ? अभी जस्ट याद आया है मुझे, अगर संभव हो सकता है तो।
Sure, please go ahead.
मेरा सवाल ये है कि जैसे मैंने अभी कुछ दिन पहले एक वेबिनार हुआ था सैटेलाइट के कचरे के ऊपर, तो जब भी हम लोग सैटेलाइट भेजते हैं अंतरिक्ष के अंदर, वो कुछ समय तक उसकी बैटरी या जो भी पावर होगा वो चलता है, उसके बाद वो पावर खत्म होने के बाद वो बंद हो जाता है और कचरा बन के अंतरिक्ष में घूमते रहता है, राइट? तो फ्यूचर में ऐसे कोई सैटेलाइट है कि जो जैसे मोबाइल रिचार्ज कर सकते हैं उस तरह से रिचार्जेबल सैटेलाइट हो सकते हैं, या फिर जो सैटेलाइट खराब हो रहे होंगे तो उसको ऑर्बिट में क्या बोलते हैं फिरने से रोकने के लिए कोई तरीका है जो ज्यादा कचरा ना हो और अपने आप क्या बोलते हैं डिस्ट्रॉय हो जाए, ऐसा कुछ है क्या फ्यूचर में? ऐसे कुछ प्लान है क्या, या फिर ऐसा कुछ हो रहा है क्या सैटेलाइट वर्ल्ड के अंदर, तो वो बता सकते हैं? थैंक यू।
Absolutely. So totally जैसे जैसे मेरे मन में there are 3 ways, right? जिस तरह से इसको स्पेस डेब्री बोलता है। तो हाउ डू वी टैकल स्पेस डेब्री? ट्रेडिशनली जो डेड सैटेलाइट्स है वो स्टिल ऑर्बिट करेंगे, राइट? सबसे पहला तरीका इज जो सैटेलाइट्स ऑलरेडी ऑर्बिट हो रही है you deorbit them and bring them to Earth's atmosphere. तो जैसे वो अगर ये Earth है, as my satellite orbits because of the gravity, वो Earth के ज़्यादा बाजू आते रहेगा and as it comes closer, it gets into the Earth's atmosphere and burns up. Right? इसी तरह से most let's say sustainable satellites have been built. Right? कि उनके tenure के बाद once their lifetime is done, they come back to Earth and burn themselves up. Part two is there's a lot of space cleaning up, right? So जैसे काफी सारी companies are coming up wherein uh, they are tracking space. So they are mapping. जैसे India से there's this company called Digantra, right? And even in the US and Europe, there are a bunch of companies who monitor space debris and some even clean them up, right? कि dead satellites को pull किया and then they either push them out or bring them in and burn it up, right? Third aspect is satellite refueling, जो mobile recharge का example था, where I really go to my satellite and pass on some fuel, and that's how my satellite keeps functioning. So ये कुछ तरीके हैं of how people are dealing with this problem today. I hope this answers.
So sorry to interrupt. I suppose that there was a recent update by NASA Goddard Space Center, and they are going to test out RRM, which is refueling missions, satellite
Correct.
refueling missions, soon enough.
Absolutely, yes. Refueling is something that people are excited about, right? Satellite servicing and refueling and so on. Definitely a near future for sure. Yeah.
Yeah, Artemis is soon going to be launched up. Yeah, quite excited. Pranit,
Artemis,
so
one day.
I hope to see you soon again with updates from Galaxeye over your over the updates about your missions and all going up soon. Wish you all the best and your company and your team. And I hope I will see you soon in Paris as well for IC 22.
Surely look forward. Thank you so much, everybody. I hope you had a good time. And once again, thanks to the organizing team. Pleasure being part of this event.
Thank you so much. Have a good evening.
All right.